record this. Right. Okay, so chaps, what it is basically, I forgot to record last time, and we were looking at the calculation P1V1 and T1 and white loss. I'm not going to go. I won't go through that again, but what I will do is just to remind ourselves. I have got. Let's have a look at this. To this one here. Let me just try and get this right. Can you see this screen?
Yes, the screen of the paper.
Yes. So can you see that bit there? Ed, can you see that?
Are you moving your mouse?
Yes.
I cannot see that.
No, I can't see your mouse
Right.
moving.
Okay, let me just stop share then, and then I'll share this screen. Okay. Yeah.
You've got a fish tank in the background now.
I'm sorry.
Is that a new fish tank?
No, it's just the
angle.
the lighting on it. What am I trying to do? Right, I want to. What can I share screen? Right. Right, this one here. Right, can you see that, guys? Now. Yeah.
Yes,
Okay. So last week, I must admit, we went through it, and I must admit, I want to go through it again. So what we're saying is, this question that we had last week on that question, multi-choice paper number 23, it said, what is the resulting volume if 0.08 cubic meters of gas at 300K and a pressure of 700 kilonewtons per meter squared is increased to 500K and a pressure of 500 kilonewtons per meter squared? We were looking at the calculation, and it's given us 4 answers. Okay.
Yeah.
And what we're trying to we went through last week, and the formula we used is P1 times V1 over T1 equals P2 times T2. So P2 times V2 over T2. That's our formula we used last week. And then we have to transpose because we're trying to find the final volume after the process. So V2 will equal, and if we transpose that formula, we're saying V2 equal P1 times V1 over T1. So that still stays the same. And then what we're saying is that T2 goes to the top there, and this P2 comes down to the bottom. So we're saying it's P1 times V1 times T2 divided by T1 times P2. Okay, so that's the formula. Then we look at what each of those terms are. So we said P1 is 700, V1 is 0.08, T1 is 300, P2 is 500, and we're trying to find V2, and we know that T2 was 500. So that's from our original question on that multi-choice test paper. And then with using the formula, we say V2 equals P1 times V1 times T2 divided by T1 times P2. So doing the calculation with the numbers, we're just saying it's 700 times 0.08 times 500. That gives us 28,000. Then underneath, we're saying T1 is 300, P2 is 500. So that multiplied gives us 150,000. And the calculation then is 280,000 divided by 150,000. And the correct answer, so V2 is actually 0.187 cubic meters. So Jack, I was just saying that doing the calculation, V2 is actually coming out to 0.187 cubic meters. And that answer that we were given, 0.187, that's that answer there. Okay. Yeah. So we can put that answer as a green one. That's the correct answer. So in that paper, then answer C would have been that correct answer. Okay, so I do apologise. We did do it last week. I just wanted to summarise it this week, so we've captured it on the paper. And this handout I will email across to you. Added to it, we might do something more tonight. So this question was number 23, where we got to, and I just want to stop screen share. So what we're saying, we've got P1V1 divided by T1 equals P2V2 over T2, and that's the formula that we use quite frequently. And what we have to get used to is being able to use that formula and transpose it, which I know, Jack, you got a weakness on that. I'll help you develop that. Yeah, on a one-to-one
Yeah.
with these sessions.
I feel like, sorry, Paul. I feel like that's more of a thing to do in person. I'm not. When you're explaining things about how to change the algebraic sums, that is a massive weakness of mine.
Okay, Edward. So would you benefit if we actually did another one of those? Okay, what we're saying, we can use the same figures. We can use the same figures and then just manipulate a formula. Okay.
It's more of the transposing the algebraic sums. It's more of why things have got to go to certain places. That's my.
Okay,
that's
I'll tell you what would be useful then is let's have a look at that formula and let's jointly transpose for everything. Okay, so what I'm saying is let me get back onto our share screen. Okay, that's fine.
Sorry, I'm having at the same time I'm having a look at what the air fryer is doing.
Okay, go on, carry on. Okay.
Right, the new potatoes are looking good.
Right, excellent.
Right, good. 5 minutes left on that.
Okay, right. So what I'm saying is, so this is the formula. Okay, this is the formula that we've got to use. So that's our common formula. And here I've transposed for V2. Okay, so let me just copy this again. Edit, copy. And if I just put it here, just down here somewhere, copy there. So we got our formula here. Yeah. So P1V1 equals P2V2 over T2. Now, what we'll do is, let's just have a look at how we transpose. Right, let's say that we wanted to find out what P1 was, okay? Eddie, you okay with this? Can you see?
Yeah, I'm still watching.
Okay, so
Not
what I'm
holding
saying
back, Eddie, am I?
No, it's fine. Like I say, I can.
we're saying, look, we want to transpose for P1 equals, okay? So what we do first of all, so we know P1, okay? Now that is going to stay as it is, that side. So P1 will equal, it'll be P2 times V2, and it's going to be over T2 to start with. So if I underline that, and then if I go here, okay. So what I'm saying is that P1 there, that side will still stay the same. Yes, that will stay the same. Now the law is, or the process is, if that V1 is above that line as it is, then we take it down to the bottom. Okay, if it's at the bottom, we'll take it to the top. So, so what we're saying is that P1, this V1 is going to go to the bottom, and this T1 is going to go to the top. Sorry, Jack. So what I'm saying is this V1 is going to go to the bottom, and this T2 will come to the top. So it will be T1, and this V1 will be at the bottom. V1. So the formula is, jack your fingers on the camera.
Oh, sorry, mate.
Okay.
Yeah.
So what we're saying is P1 is equal to P2 times V2 times T1 divided by T2 multiplied by V1. So we've got that bit there. Okay. Does that? So all we're saying is we've just taken that to there. Oops, sorry. How do I show you that? Let me just try that. Okay, so all I'm saying here is, I think what we need to remember is that note. So the opposites, I'm saying the formula opposite, or the formula on the other side of the equal sign remains the same. Okay, that's first and foremost.
Right.
Okay, yeah. So what I'm saying is we looked at P1 and we said this formula on the other side of the equal sign remains the same. Okay, so that's point number one. Now, point number two, looking at the original side, of the equal sign, okay, if the term is above the dividing line, if the term is above the dividing line, then we move it to the bottom of the line.
So you're saying in turn, if you were to move
V1, V1
on the other side, you have to move to the other side.
Yes. So I was saying, looking at the original side of the equal sign, if the term is above the dividing line,
yeah, it's 2 seconds.
then we move it to the bottom of the line.
Okay, I can show you. Paul, I've got headphones in. I've just got to check the potatoes as well. It's gone off.
Okay. So what we're saying is, if the term is below the dividing line, then it is moved to above the dividing line.
So that's what you meant when you said opposites, yeah?
Opposite, yeah, that's right. Yeah, yes, opposites. So what I'm saying is, basically, so what I'm saying is, the formula on the other side of the equal sign remains the same. Looking at the original side of the equal sign, if the term is above the dividing line, then we move it to the bottom of the line, dividing line. And if the term is below the dividing line,
it goes to the opposing side, which being the top.
To the top. Yeah, to the top.
Is that actually it then? Is it? That's the case of all algebraic sums.
In this case, that's it. That's what we're looking at. Yeah, that's the trick. So we've got here. So we've got the formula here. Yeah, P1V1 over T1 equals P2V2 over T2. And then we're saying, look, P1. I'll just copy this again. Copy. Right, so let's do it for V1 then. Okay, so let's say we were going to transpose for V1. Okay, so I'll put that underline that. Right, so if we're transposing for V1 there, we say, right, V1. So V1 is going to equal. Now we said that's V1, so the other side still remains the same.
Right.
So that is still P2 times V2 underline that. So P2 times V2 over T2, that remains the same. Okay. And now what we're saying is we're trying to find V1. So we've got to get rid of this P1 and T1. So P1 will move to the bottom
bottom and T1 to
and
the top.
T1 to the top.
Okay.
Yep. So V1, we got V1, P2 equals V2 over T2. That remains the same. Then we're saying the T1 there is going to be at the top now because it was at the bottom.
Now it changed.
And then the P1 here, because it's at the top there, go to the
Go
bottom.
to the bottom. Right. Then divisible by P1.
Yeah. Yeah.
Yep. No, yeah, I see that now. No,
Okay.
the
So let's
notes have been
now.
added.
Okay, let's now transpose. Transpose for P2. So we want P2 equals. Right, so Jack, so let's do the first bit. So what's P
Right.
to start with? P2 equals.
P2 equals. So as it changes, P2 will be the divisible sum.
Yeah, so what's the first bit? What are we going to write?
T2.
We've got P2
Yeah, equals.
equals, yeah.
It's P1. That side stays the same.
Yeah.
Oh, okay, that's what I was
P1
okay.
times V1.
Yeah, the left side's okay.
Yep.
P1.
Divided by, so we're going to move this over here. So P1 times V1 is going to be T1. You can't get rid of that.
Yep.
Underline. Get rid of that there. Okay. Now what we've got to do is we've got to say, right, now we want P2. So we've got to do something with V2, which is at the top. And we've got to do something with T2, that's at the bottom. So
Yeah,
if looking at T, well, we got V2 here. Yeah, that V2 is going to go to the bottom because it's at the top. Yeah. Because it's at the top, it's going to go to the bottom. So that's going to be T1 times V2, and then this T2 here is going to go to the top.
Yep. Stop.
Because it's at the bottom. Yep, so if I wanted to find out P2, I'd quite simply say it's going to be P1 times V1 over T1 and multiplied by T2 and divided by V2, which is what I've got here. Yeah. Ed, does that follow with you?
Yeah, I get that, mate.
Yeah. Jack?
Yes. Sorry, mate.
Right, let's just I'm saving this. Okay, I'm saving this. So let's jointly then look at, we've done it before, let's look at V2 again. Okay, so we're saying we're going to transpose for V2 equals. Okay, so we're looking at that bit there. Yeah, so we're looking at, if I can I do that one there? Looking at V2. Okay, so V2 equals. Yep. I think he's going to get his.
Yeah, no, so I can still hear you, mate. I'm just.
Okay, all right. Okay, so what we're saying, we've got V2. So we're saying we've got V2, and the opposite, this side is going to remain the same. So that's going to be V2 will equal P1 times V1 over that's going to be T1 okay. And then we're saying this P2 has to go to the bottom and this T2 has to go to the top.
Yep.
So V2 will equal P1 times V1 times T2 over T1, there, and that P2 goes to the bottom times P2. Right, where it gets a bit more difficult now, okay, where it gets a bit more difficult is if I wanted to find out for T1 or T2, because these are underneath the dividing line. Okay, we are going to do it. We are going to do it. So if I copy this out here, in fact, no, let me copy this one here. Copy. So I've got this. I've got this here now. This formula. Ed, are you still there?
Ed?
Ed? Yep. Okay. Got you. Okay, Jack, you anywhere close
Yep,
now?
sure. Yeah, I'm nearly, mate. I'm just dishing it up now.
Okay, because what I'll tell you, this is important because we're going to. So this is a bit more complex. Okay, so we're going to transpose for T1. Okay. So whilst we're waiting, Ed, do you want to hazard a guess as to what we might need to do?
So if you want T1 on its
We're
own.
trying to find this one here. T1, that's what we're trying to find. Okay.
So T1, would P1 and V1 go on the bottom next to T2?
They will do to start with. Okay, they will do to start with. Okay, they will do.
Okay.
So what you're saying is, I'll try and do it in stages. So what you're saying is, let me see if I can do this. I'm not. If I go to edit and copy, let me see if I can. Right, I've got that copied. Right, we're trying to find T1. Okay.
Yep.
So what that means is this one here.
Yeah.
Okay. So we've still got the line. So
yeah,
that's P1.
Yeah.
Times V1.
Yeah.
Comes there. Okay. And
so T.
So what we're saying is that we've got that there. Now what we're saying, this is underneath the line here. So we're saying that over is equal to that. So what we do is we turn it upside down.
That's right. Yeah.
Yeah, we now have to turn the formula upside down. So what we're saying is we will have T1 equals, so that's the line now. You see what we've done is the line now is underneath. Yeah, so that's T1. Okay, Jack, I hope you're enjoying that, mate. You're making me feel hungry. Although
it's the second thing I've eaten all day, Paul. I'm starving, bro. It's the second thing I've eaten all day.
No wonder you're keeping fit, I tell you. Okay,
it's a hard day, bro.
No worries. Okay, so what we're saying is, just to summarise, we're saying when we want to look at T1, what we have to do, we have to get rid of P1 and V1 now because they're at the top of the line. They'll come to the bottom, underneath.
Yeah.
So that leaves T1 will equal P2 over V2 divided by T2 times P1 times V1. Okay. Now we turn it upside down, so we get T1 on top. So that's T1. That means we turn this upside down as well. So the actual formula for T1 is going to be T2 times P1 times V1 divided by, and that's going to be, so that bit there goes to the underneath. So that's going to be P2 times V2. And I'll just get rid of the line here. So what we've done is we've actually turned it upside down. Yep, so T1 is actually going to equal T2 times P1 times V1 divided by P2 times V2. So we just turned it upside down. Physically.
You've entirely flipped it.
Sorry?
You flipped the equation.
Flipped it, yeah. Inverted it, flipped it, upside down, whatever you want to call it. That's what we've done mathematically. Okay, and the same thing applies if we wanted to look at T2. Okay, so if we wanted to transpose for T2, I'm going to save it as well. So transpose for T2. So we've got this formula here. I'll use, let's get this here. I'll do edit copy. And so we're saying, right, we've got the formula here. I'm going to flip it, I'm going to go down the page, otherwise I'll be running out. So now we're trying to find this bit here. Back there. So our process is to get T2 on its own. So if I just copy this out here, edit, copy, and let's just do that bit there. Now, what we're saying is that's to this P2 now and V2 is going to come to the bottom here. So that's going to be, I'm just going to times P2 times V2. I'll just move that across there. So that gets rid of that.
Yeah.
Okay. But that line,
yeah, still there.
Is still there. So how am I going to get that? Okay, let me just go backwards. Okay, let me just, if I can. No, do that. Let's do that there. That's it. I got it. No. Oh, that's fine. Yeah. Okay. Maybe I'll do that one. I can't do it over the top. Oh no, let me just try it. No, no. Yes. I'm not let me just try this. Right. There you are. Got it. Okay, so does that make sense now? Yes?
Yeah.
And then what we're saying is we then now flip it upside down. Now we flip it upside down. Okay. So what that means now is basically we're saying that T2 is going to equal, so that goes to the top. Okay.
Yeah.
That goes to the bottom.
Mm-hmm.
So we're saying it's going to be T1 times P2 times V2 all over P1 times V1. So what we're saying is that we go through the formula there. I'm just going to write here as a heading. Transposing the formula.
Okay.
Okay, as a heading. So we've got P1 times V1 over T1 equals P2 times V2 over T2. And then what we're saying, basically, the formula on the other side of the sign, equal sign, remains the same. Looking at the original side of the equal sign, if the term is above the dividing line, then we move it to the bottom of the dividing line. If the term is below the dividing line, then it's moved to the top of the top. Well, wording better, above, to above. Above the dividing line, basically opposite. Okay. And when we're looking at down here, we just have to look at flipping the formula down.
Okay.
So just to prove the formula, okay, just to prove the formula, proof. Saying T2 equals, okay. Now what I'm going to do, I'm going to go back and pick up all these terms. Okay. Now we've found that first answer, and I'm going to put into blue. That was 0.187. Remember? Yeah.
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 Yeah, that was the answer. So I'm just all I'm saying is by rearranging the formula, we should get the right answers. So I'm just going to now. I'm going to copy that. Edit. Copy. So we've got that, and if we just say proof, okay, and we'll copy that there. So those are the, and using the formula, well, that's the formula, okay? That's the formula. And if we've done it properly, then we know that T2 should come out at 500, okay?
Yeah.
It should equal 500. So what we're saying is T2 should equal 500. So if we've done the transposition correctly, we use a formula. Okay. Equal there. So we're saying, look, T1. Okay, T1 is 300. 300 multiplied by P2. P2 is 500. Multiplied by V2. Now V2 we found as 0.187. Okay, that's what we found out as the answer. Right. So it's going to be times 0.187. And that's going to be over, we're saying it's going to be P1. Now P1 is 700. times V1. Now V1 is 0.08. 0.08. Okay. Now, if we continue to do the maths, okay. Right. So if we do the maths, right, let me just get the maths. Okay. So what we're looking at is this. We're saying it's 300 times 500 times 0.187 equals, so that equals 28,050, okay, as a value. Now we're going to divide that, and we're going to divide it by 700 times 0.08. So it's 700 times 0.08 equals 560. Okay. I'm going to get rid of it there. Right, so doing the math then, what we're saying is on the calculator, right, so 28050 divided by 560 equals 50. That's not what it ought to be. I've dropped a zero somewhere. Let's have a look. Was that 0.87 or 0.087? Let's have a look. Okay. No, that's fine. I'm happy with that. Right. So that's 700. I've got 700 there. V1.08. 300 is fine. I've done that. Let's just do that. So what I'm saying is it's 300 multiplied by P2, which is 500, multiplied by 0.817. That's fine. Happy with that. Then we're saying it's 700 times 0.08. Let me just do the maths again. I may drop a note somewhere. Right. So we're saying 300 times 500 times 0.187 equal 28050. Okay. And 28050. And then we're saying 700 times 0.08 equal 56 for an extra naught on. So my apologies. So 700 times 0.08 is 56. Okay, so if we do that, we're saying 28050 divided by 56 equals 500. Yeah. Equals 500, or like 500.8, but that's as close as down. So that's proven it. That's proven the formula in the sense that we've transposed it, we've got the correct terms, we've put the correct terms, values, numbers, and then by doing the mathematical formula, we know that T2 should be 500, and it is. Okay. So
because you transposed the formula and then rearranged it.
Yeah, that's it basically.
To get the values.
Yeah. So what I'm saying, I mean, if you get to high level math, they actually say, transpose this, and then they'll say, prove it works. And the proof is actually using the formula with the numbers and making sure the calculation works. Okay. So what I'm saying is, this is level 3 stuff you're doing now. In fact, I would go and say, yeah, it is level 3. It is. Yeah, but the proof of it, doing it, is actually level 4. So does that, what I'm saying, does that make sense?
Yeah.
Jack, does that?
So, as much as it could at this current time, Paul, yeah.
Okay, I think what I want to do is, because it is late, okay, and you've had a long day as well.
I mean,
yeah, go on.
obviously, Paul, the algebraic side is my weakest side. I was hoping you were going to show me question 5. I mean, the actual, they're putting it into practice in fault finding. That's my strongest side.
Question 5, sorry. What did you say?
Question 25. 25.
25. Okay, should we look at question 25 then?
Yeah, I'm
question
happy
B. Reduction in pressure.
Okay, let's have a look at this then. I'm going to say this first of all. Okay, so let's go to the. I'm going to stop sharing for a while. Okay, let me just share the screen again. And we're looking at this paper here, 25.
Yeah, that's the first question I saw, and I thought, oh, okay, we're in for an easy one here.
All right. Okay, let's go through this. All right. So we'll do as much as we can. Ed, you okay with that? Ed, are you okay?
Yeah, I'm okay. I'm okay with
I
it.
don't know what to say.
All right. What I'm saying, I think what we'll do is I'll finish at 8:30. If that's okay with you guys. Give you time to breathe and enjoy the family or the room. Right.
Yeah,
what I'm saying here is number 25. Okay. What causes flash gas in the line after a partially blocked filter dryer? So you've got filter dryer on the liquid line, and if you've got partial blockage, then what creates that? What happened?
B. It's a B. It almost acts as
reduction
an
in pressure.
expansion valve.
Correct.
Yeah,
It's a
it
reduction
almost
in
acts
pressure.
as an expansion valve.
Exactly. And that's exactly what we said
Because-
last time as well. I remember from last week. So yeah,
Did
because
we say
it's
that
acting
last
like the
week?
expansion valve, because it's acting
Yeah,
like the
we said that
expansion
last week.
valve, we're getting basically subcooled liquid going through the dryer. With a restriction, it's restricted and expanding. We're getting flash gas, which is flash gas is another term for saturated mixture. It's a mixture of liquid and vapor. Ed, are you happy with that term, flash gas?
Yeah, yeah. I understand that. That's fine.
Yeah, brilliant. Okay, if we look at the next one then, number 26. What must be present for the pressure temperature relationship to be correct? Okay, so we're saying we know refrigerant, we got the pressure matches the temperature and temperature matches the pressure, but it'll only be under certain conditions when that will be. Okay, and it's asking when, what do we need to have for that to exist or for that to marry up? So must we have superheated vapor, saturated liquid and vapor, subcooled liquid, or subcooled vapor and superheated liquid? So which one of these
B.
confirms that the pressure temperature relationship is correct? B.
B.
Correct, yeah.
Oh,
It's got to be a mixture.
It's a B, man.
It's got to be a mixture of saturated liquid and vapor. So it's mixture. So 50-50, 90-10, 80-20. As long as we've got
80-20.
a mixture of liquid and vapor and it's changing state as is, it's either absorbing heat in the evaporator or rejecting heat at the condenser, then that pressure temperature relationship will confirm itself. Yeah.
Yeah, 80-20 is the sweet spot, isn't it? Before the expansion valve.
Sorry, Jack, was that?
80-20, the mixture before the
Yeah,
expansion
it
valve.
depends. I mean, no, 80-20 is after the expansion valve.
After-
Before
sorry,
the expansion
after.
valve, before the expansion valve,
I'm
we
talking for
want
liquid.
100% subcooled
Yeah.
liquid.
Hmm.
You want 100% subcooled liquid.
Yeah, we don't want to send gas to the expansion valve, of course not.
No, because we
would-
wasted. We wasted the energy.
That'd be a shit system.
We wasted the liquid, which would have absorbed more heat in the evaporator. Okay. Right. This one here then, number 27. Okay. What effect does subcooled liquid have on a system performance? Okay. So what effect does subcooled liquid have on a system performance? Increased cooling capacity, increased discharge temperature, decreased discharge temperature, or decreased motor current?
Oh, pardon me.
So what do you reckon, Ed?
Definitely not A or D. And subcool. I'd go for B again.
Okay, the situation is, Jack, what do you think before I Any comments?
So what effect does subcooled liquid have on the system's performance? Well, if it's
Yeah.
smashing the
So what I'm saying
compressor,
is, if we don't have subcooled liquid, what happens? And if we do have subcooled liquid, what does happen? Okay.
well, yeah, no, I'd say be in the same point, because if you're bringing liquid back to the compressor, it's going to be increased discharge temperature.
Yeah,
The
but what I'm
pressure's gonna
saying,
be
this is not saying we're getting liquid back to the compressor. It's saying that we've got subcooled liquid.
what within the system
Yeah,
at all.
where it ought to be in the liquid line.
Right. Okay.
Okay, so it's what I'm saying is, let's say we're condensing at 40 degrees C, and if we've got a liquid temperature of 40 degrees C, or we get with subcooling, let's say we take it down to 32, so 8 degrees of subcooling, what effect will that have on system performance?
Sorry, I'm taking my headphones out. 2 seconds.
Okay, the correct answer, the correct answer is actually A, increased cooling capacity. It's actually increased cooling capacity. And what I'm going to try and do, if I can, is see if I can actually show you that on. How do I? Okay, right. So that's the correct answer, first of all. Let me just see if I can go into.
Oh, there we go.
I just want a pH chart. Okay, right.
There you go. That's good.
Okay, let me just. So this is. I'm going to try. If I can. I don't think I can. I'm going to draw a line here. Draw.
Oh, I can't see what you're seeing, Paul.
You can't. Okay, sorry.
No.
Resume.
Don't
Resume share. Okay. Right. What do I want? I want to pressure enter the diagram. Really. That's all I want.
Oh, okay. I still can't see it.
Okay. Let me get something sorted out for you first.
Right.
Let me get it up, and then I'll share screen with you in a minute.
Oh.
Okay. Now, I'm just going to do something. Right. Right. Let me just. I'm going to stop screen share, and then I'm going to share another screen. Right. Can you see this screen now?
Yes.
Okay. Can you see this?
Yeah, basic
Okay.
pH chart.
So what? Yeah, pH chart. So what we're saying is here we've got compression, evaporation, condensation, and expansion here. So what we're saying here is basically that is the refrigeration effects here. Yes, that's the capacity of the evaporator. That length of line there. Would that follow?
Yeah.
Right. Yeah.
Now what we're saying is if we've got subcooled liquid, and we got this line here, that there. So instead of, I don't think I can. Can I move it? No, I can't. What I'm saying, so instead of it being, see that's saturated liquid coming out the condenser and going into the expansion valve. If we had subcooling here, and then that line was here, so what I'm saying, this might be at 80-20, 80% liquid, 20% vapor. If I've got subcooling, then that's going to be closer to here, and that might be something like 95% liquid and 5% vapor. So by having that subcooling here, it means the system performance, it's increased. We're getting better cooling. We're getting more cooling, more refrigeration effects. Because we've elongated that line back here. We're making more use or better use of the evaporator.
Right.
Yep, so increased subcooling, okay, increased subcooling or having subcooling means that we are increasing the cooling capacity. Yeah, because that there is saturated liquid, and we're extending that line to be here. So it's getting closer to saturated liquid, 100%. So let me just. See here? Can you see this one here now?
Yeah. Right. Yeah.
Yes, but so we said before, look, we were here at that point there. Yeah, because that was saturated liquid. Now we've got subcooling. We've actually elongated that. We've got better refrigeration effect. So
Yeah.
we're getting better. So the system performance increases if we have subcooling. And that's all we have it. If we had a situation where we weren't reaching that line, and let's say we were hitting the expansion line or the expansion valve here, there, what's going into the expansion valve? If it actually dropped into the expansion line there, sorry, into the expansion valve here. So instead of it being here, subcooling, we were here. We didn't actually hit that saturated liquid curve.
You getting some gas in there?
Yeah, you're hitting
Sorry, what was that,
vapor.
Ed?
You getting some gas in there?
Yeah, what I'm saying, in the liquid line, it's not fully saturated liquid, so it'll be a saturated mixture. So it's a bit like having a block dryer in the liquid line, and then that saturated mixture is going to the expansion device. You've lost that evaporation process. Yeah, so that will actually reduce system performance. Okay, so ideally we're saying we want some subcooling here. Saturated liquid is okay, not that bad. And worst case scenario, we have 9 to 10 mixture coming into the expansion device. So that's really bad, that is. Okay, so we want to have subcooled liquid entering the expansion device to make the system performance better, increased. Okay. So
Then.
Right, let's just stop there. So what I'm saying is, the reason why we have subcooling is to make the cooling capacity better. We're increasing cooling capacity, okay, and that's better for the system. We can have too much subcooling, which means we won't put enough heat into the evaporator to boil off that liquid because it's subcooled too much. And then we might get liquid going back to the compressor, which is what we don't want. Okay.
No, liquid flow back, bad.
Yeah, you don't want liquid flow back. So what I'm saying is that is where we're at. I want to leave it. It's now 8:30. I want to park it here, in the sense that we've looked at that P1V1 T1 formula again. We've looked at how to transpose it, and I've written that on a handout now for you. Okay. And then we've looked at some more questions on the sample test paper. And what I will be doing is, because I've recorded it now, I can actually send you a link to this video. So what we've done today is basically, level 3 work. Level 3, P1V1 over T1. Okay? And the fact that I've done it and I've recorded it, it's good because I can actually play it again now.
Yeah.
And I will put this on LinkedIn, not on LinkedIn, on YouTube, and send you a link to that.
No, it's not good enough to go on LinkedIn.
No, it's not good. No. What I'm saying is, it will be on LinkedIn. I did put something on LinkedIn. I think last time I put something on. I did. I'm pretty certain I did. I'll have a look at it. But what I'm saying is, having something like this, because with LinkedIn, guys, we can only, or on Facebook, you can only have 15 minutes of a lesson. That's all. So we've done now. We've probably spoken for I would say, about an hour. We've spoken for about an hour now, and I can't condense that into 15 minutes. Well, I can. I'm going to try and trim it so that so we actually have a look at it. So what I'm saying is, what you will get is access to the link, which gives you the whole lesson because you're part of it. It's yours. We put it together. I'll email the handout to you as well, so you can actually see what we've done. Okay?
Yeah.
And having the handout, having the video, access to the video on YouTube unlisted, it will allow you to actually play it back again. And the beauty is that, seriously, you've taken no notes, have you?
No, I mean, all I've got is paper plates and knives and forks here, Paul. I'd have to take notes.
Well, next time, can you try and have a pad and some pens? Yeah.
Oh,
yeah.
next time. Oh, stay on that, Paul. So next week I'm on nights.
All right. Okay. Well, maybe Ed and I'll just continue, or we can postpone it. How long are you on nights for?
How long am I on nights for? Wednesday, Thursday.
Who's with you in the room?
Oh, it's the electrician. He was sitting along.
Hi, electrician. How are we doing? All right.
He did his F-gas, and I thought he could sit along with me and try and.
Did he? Has he done the F-gas?
Yeah,
Don't
he's
teach
done his
electricians
F-gas.
anything. They're dangerous.
Yeah,
What
they
was
are
that?
dangerous. That's correct. Yeah. No, he did his F-gas, and I wanted him to sit along with me and see if he could take in any of this because I'm shattered.
Right. No, this is beyond F-gas, I must admit. Some of the questions are. But certainly, we've been doing F-gas today, and we've had a lady on the course, a husband and
Oh,
wife
wow. No
from
way.
Romania. Yes. Very much so. Yeah.
Wow.
What I'll do, let me just, I can share this with you.
That's it.
I'm sure she won't mind.
Just use it to have you less.
Let's have a look.
No.
Are you guys in a hotel staying away then?
Yeah, mate.
Can you see that at all?
I'll just quickly show you, bro. Hang on. I'll just turn around. Bro,
Yeah.
we've got an air fryer in the room. I'm eating off paper plates.
What, in the hotel room?
Yeah, I've got an air fryer and paper plates, Paul. I'm living in poverty, bro.
I'll tell you what, how have you managed that?
Well, I brought the air fryer from home.
Seriously?
Yeah, and I've also
That is a good touch. That is a good touch.
fridge right here.
Yeah,
Little fridge, hold all my goods.
right, okay. I would have to fill with cold drinks, isn't it?
Yeah, mate, it was icing up earlier. It's all it is a heat exchanger and a fan.
Yeah, right, okay.
It was.
Okay.
It's still,
I like the touch with the air fryer though. I do like that. I've
Well,
had
it's
people
like-
putting toasters, and
Well,
one of my friends from in Hull, he travels from Norwich, I think it is, an Asian guy, a doctor, and he brings like a slow cooker from home.
I was gonna.
So he puts what it does. He tells me. He told me, he says, in the morning you'll put all his lentils in, the vegetables in, all that, lot. And then as he's at work, it's on slow cook. So by the time it comes to the hotel room, his food is cooked, you know. And all you have to do is go to the local, get some naan bread or something like that. And
The only issue I've got with that is that they always book me a Premier in, so as soon as I take my card out the wall, my slow cooker stopped working.
No.
Ed, if you put a fork in that socket, bro, it will carry on. All it is
I know, mate.
it's a switch.
It's just a pressure switch, it's just like a switch.
Just smash a fork in it, bro. It's all good.
But I can't believe you're away and they're not looking
I'm hopeful, Jack, that what you're telling you, it's a plastic fork and not a metal fork.
No, because it won't make the switch if it's a plastic fork. You've got to make the
Got you, right. An insulated handle then.
Yeah. We'll tape it up first. Bro.
Yeah,
tape it up
got
first.
you. We're a bit of lagging on there.
Yeah, exactly.
We are
Very
experienced
safe.
now, aren't we? All right, chaps. Listen, I must thank you guys. Thoroughly enjoyed it as always, and I'm hopeful that I've now recorded it, and I'll send out the link to the recording and also the handout as well. And Ed will touch base next week. All right.
Yeah, sure. Okay.
In the meantime, Ed, can you try and have a look at the job write-up for me, please? Try and have a go at doing one.
So yes, I'll give you a call tomorrow.
Yes.
And if you tell me what you want out of them or what type of jobs, I'll look through. I've got like 50 on my stack on Job Logic, so I'll look through what I've been doing. And I'll pull the ones that are
all right.
Job Logic.
What are you doing tomorrow?
Job Logic. You work for Pure Cold?
What did you say, Joe?
No. He doesn't work for Pure Cold, no.
Oh, not Pure Cold. Okay, I had Job Logic. I thought it was
Pure Cold. Who works? Jason Bennett, isn't it?
Yeah, Jason Bennett. They use Job Logic or Verify, but I don't know if he's JCW or Pure Cold.
Yeah, I was talking to another one of my engineers, and he was saying that Job Logic had actually fouled some of their systems up, all their records and stuff.
Yeah.
So they've gone
it's shit out. It's terrible.
Isn't it? All right, guys. Good evening.
Nice,
I'll see you next week.
Thank you,
guys.
Paul.
Thank you. Enjoy the rest of your evening. Cheers.
Thank you, bro. Love you.
Bye.